All right, so let's talk a little bit about the periodic table in depth, okay? Um, Dmitry Mendeleev, who is credited for the invention of the periodic table, or its kind of organization, he wasn't the only one, but he published a paper early on that showed that organizing elements into groups like this could be predictive in their properties, all right, and reactivities and all sorts of different other properties that elements have, and it became helpful. He predicted the existence of elements that were later discovered, and these predictions really cemented his impact on the periodic table, so he's credited kind of for its invention. And what it's doing, the periodic table, what it does for us is it organizes our elements into periods and families, or rows and columns, okay? And our columns have very similar properties. Elements in a column have very similar properties, one with another, okay? So there are some important groupings on the periodic table that we want to become familiar with so we can refer to them easily. The first group is the first two columns and the last six columns. So we have these two columns here and these last six columns here, and that group together, those 8 altogether, are called our representative elements, okay? We call them that because there's a lot of rules that we used, introductory rules, to talk about how chemicals interact with each other, how elements interact with each other. And these groups follow very nice rules, and so they represent those rules very well. Whereas our elements in here are a little bit more difficult to understand why they perform the chemistry they perform. We call these transition elements. And then down below here we have our inner transition elements. Okay. All right. Group 1A are known as our alkali metals. They are very reactive. They explode generally when placed in water. Lithium, sodium, that's why lithium ion batteries are very, you have to be careful about where you ship them if they're on airplanes, because if they catch on fire up there, that's a problem, right? So very reactive, everything in this row here, all these metals. Also, our alkaline earth metals are relatively reactive, not as reactive, but they're also reactive. Then another group over here, we have our halogens. Halogens, very similar properties: fluorine, chlorine, bromine, and iodine. Okay, and we'll refer to them frequently. The last column, which is probably the most popular column, which we'll refer to most frequently as well, or very frequently, probably most frequently, is the noble gases. All right, all the elements have a tendency to want to arrange themselves to have the same number of electrons as noble gases have. Okay, so there's a degree of stability associated with having the number of electrons that these noble gases have. The periodic table will generally, or should be, kind of laid out like this, but for our 8.5 by 11 paper, this is what we generally see. This here will be a little less useful as well, because our inner transition metals we're not going to be utilizing nearly as much as the rest of them. So if they were to take up such a large portion of the space, central space of the periodic table, that would be less useful for us. Again, this staircase separates our nonmetals from our metals. All right, we have our metals in green here. Hydrogen is our exception for our nonmetal. So here's a question: which of the following is correct? I'll let you go back and look at the different slides that we just looked at and try to answer this question. All right, push pause and do that. Okay, when you're done, come on back and Fred will tell us the answer. What do you think, Fred? What's the answer?
I really can't remember.
Okay, well, let's bring out the periodic table. What we got?
Copper. Where's copper?
Copper's number 29 here.
Well, that's not a representative element. That's a transition element, so that's not right. Na is an alkaline earth. That's right, right?
Na's over here on the left. Do you remember, is that alkaline or is that alkaline earth?
Oh, that was just an alkali metal. That's right.
Good, so B is not correct. Is C a semi-metal?
Semi-metal. What one's the semi-metal?
Semi-metals are the one along our staircase here. So boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Okay?
Okay, so it's not that. Carbon's a non-metal. Fluorine is a halogen. Yes, fluorine is a halogen.
Very good. So D is correct. Excellent job. Okay, so metals, they reflect light, they're shiny, right? They're malleable. Now, this isn't a property that we're always familiar with when we think of metals, because our forks and knives, the chairs on legs, or legs on chairs, which are metal often, right? Things like this don't bend. They're not easy to bend. Jewelry, it doesn't bend very much. But metals, pure metals, elemental metals, they are very malleable. So here's an example of a metal. This is sodium metal. It behaves, well, it looks kind of like a piece of cheese. It's much stiffer, but you can see it just takes a little bit of muscle and a chisel there, and we can kind of open it up. The white fuzz, or white dusty material on the outside, is the sodium oxide that's forming from the sodium metal interacting with the water and the oxygen in the atmosphere. All right, and they put a piece of sodium metal like that into this container up here, which you call a desiccator. The desiccator has material on the bottom that absorbs water, so it prevents it from reacting. Okay, and you can seal up the desiccator. There's a little bit of gel there, a little bit of grease to help get a good seal. All right, so metals conduct electricity. They're solid at room temperature, except for mercury is an exception, right? And then we have an example here of putting some sodium into water at night.
We saw that before.
Well, we saw it before, but not at night.
Oh yeah, that was a night.
Okay, very good. Now we have another video of a group. They're going to put not sodium, but they're going to put two other metals. This is rubidium, and see where rubidium is on the periodic table. Rubidium is below sodium, so sodium is more reactive than lithium. Potassium is more reactive than sodium. Rubidium is more reactive than potassium, and cesium is more reactive than rubidium. So this is rubidium. It's going to go into the periodic, or into a bathtub full of water here. So let's listen as they put it in. All right, so we saw an increase in reactivity as we moved down our periodic table there. Okay, so now we're going to go and talk a little bit about our nonmetals. Nonmetals, not conductive, not shiny. They can be colorful, but they don't conduct electricity. Most are, well, some are solid, many are gases. There's only one that's a liquid, and that's bromine. Okay? They combine with metals to form ionic compounds. Nonmetals combine with metals to form ionic compounds. Metalloids, as we mentioned, very important area of the periodic table, allowed us to understand so much about, Just picture my daughter being silly. Allows us so much to do so much. Silicon allowed us to develop computers, right, and storing data. So understanding the properties of these metalloids were critical. Still very critical, not just for storing data, but for converting light into energy in the terms of in the form of photovoltaics, right? So yeah, lots of big contributions that these nonmetals or metalloids make. Now, an ionic compound. We'll talk about ionic compounds when we come back next time, okay?
Okay.